Hello everybody. I'm going to go through a few more horsepower examples in this video. In a previous video we talked about work being measured in foot-pounds. Power is work per time, so foot-pounds per second. And then 1 horsepower would be 550 foot-pounds divided by 550. So let's look at an example with a pump. Let's say we have 500 pounds per second going into the pump at 0 psig, and then our discharge is 100 psig, and this is water, so our specific weight is 62.3 pounds per foot cubed. Okay, we need to convert this pressure to feet of water so that we can use our equation. So the 100 psi times 144 inches squared per foot squared is 14,400 pounds per foot squared. And then to get feet of water, we divide this by the specific weight. So 14,400 divided by 62.3 equals 231 feet of water. Okay, so we have the feet and the pounds per second, so now we can use this equation. And plugging in our numbers, we have 231 feet times 500 pounds per second divided by 550, and that equals 210. And that is actually the horsepower imparted to the water itself. And typically with a pump you need to find the brake horsepower, which is this hydraulic horsepower divided by the efficiency. So let's just say this pump is 75% efficient. So 210 divided by 0.75 is 280 horsepower at 75% efficiency. Okay. Another example, let's see, we have a fan and it's blowing 20,000 CFM, and the change in pressure of that air across the fan is 2 inches of water. So just like the pump, I need to convert this pressure, which is measured in inches of water, to feet of air. So as you know, 1 cubic foot of water weighs 62.3 pounds. So if you can picture a cubic foot of water, 1 foot on each side, it would apply a force of 62.3 psf at the bottom, and then to convert that to inches, that pressure, we would divide it by 12, and then so this is the pressure from 1 inch of water in psf, and then to convert that to feet of air, we need to divide by the typical density of air, which is 0.075 pounds per cubic foot. And then I'm just going to carry on with this. It'll make sense later. We multiply times the density of air and divide by 33,000, and all of this equals 1 over 6356, which is part of an equation you may have seen for air horsepower, which is this. I'll write it out. Air horsepower equals CFM times change in total pressure in inches of water divided by 6356. So what this is doing is converting inches of water pressure to feet of air, and using the density of 1 cubic foot of air, it all converts back to this equation. So let's plug in our numbers. Air horsepower equals 20,000 times 2 over 6356, and that equals 6.3 air horsepower. Now, similar to the pump, we need to divide by the efficiency of the fan to get the brake horsepower. So let's say this fan is 60% efficient. So we just divide 6.3 by 0.6, and our brake horsepower will be 10.5. Okay. One last example would be the plan formula. Let's see, I'll write it here first. Horsepower equals plan over 33,000. And this applies to internal combustion engines. So let's say we have a cylinder here. We're looking at a cross section of it, and it's in a V8 engine. Let's say the area of the cylinder is 0.1 feet squared, and then the stroke of the cylinder will be 1/2 of a foot. So we need some more information. We need to either calculate or assume an average pressure over this power stroke. Let's say it's 70 psi, and that equals 10,080 psf. And we need to know the RPM. We'll say 2,000 RPM. And then the plan stands for pressure, length, area, and then the number of power strokes per minute. So we have the first three. The N will be 2,000 RPM times 8 cylinders, so that would be 16,000. But if this is a 4-stroke engine, we have a power stroke on every other cycle, so we divide that 16,000 by 2, so N equals 8,000. Now if this were a 2-stroke engine, N would be 16,000. Okay, so let's plug in our numbers. We have 10,080 times 1/2 of a foot times the area, 1/10 of a foot squared, times 8,000 over 33,000, and that equals 122 horsepower. Now you may have seen this equation where pressure is in PSI, and I believe length or area is in inches, area is in square inches. When I first came across this equation, I noticed that, and it all cancels out to the same result as if you were to have PSF and length in feet, area in feet squared. So I like to do it that way, just so that I have all my dimensions or variables in feet. That way I don't have to remember which one is in feet or inches. So in this example, and actually all the other examples, we just have feet, like what's in the equation, and pounds, and then seconds or minutes. Okay, so thanks for watching the video. Let me know what you think in the comments. Thank you.